Welcome back to my channel. In my previous video discussed about linear partial differential equation of order 1, Legranges method type 1. Now Legranges method type 2. Solve first problem. Solve p plus 3q equals to yz plus tan of y minus 3x. Solution. Comparing the given equation. Comparing the given partial differential equation. Capital P small p plus capital Q small q equals to R. We have capital P equals to 1, capital Q equals to 3, capital R equals to yz plus tan of y minus 3x. We have read the Legranges auxiliary equation. Legranges auxiliary equation. Auxiliary equation is dx by p equals to dy by q equals to dz by r. Dx by p equals to 1, dy by q equals to 3, dz by r equals to yz plus tan of y minus 3x. First two fractions. Dx by 1 equals to dy by 3. Dx by 1 equals to dy by 3. 3 into dx equals to 1 into dy. 3 dx minus 1 dy equals to 0. Integration on both sides. Integrating on both sides. Integration 3 dx minus integration 1 dy equals to c1. 3x minus y equals to c1. U of x comma y comma z equals to 3x minus y equals to c1. Next we have taking first and last fractions. dy by 1 equals to dz by yz plus tan of y minus 3x. Dx by 1 equals to dz by yz plus tan of y minus 3x. Dx by 1 equals to dz by 5z plus tan of 5 minus 3x. 5 minus 3x equals to c1. Tan c1. Integrating on both sides. Integration dx equals to 1 by 5 integration 5 dz by 5z plus tan c1 equals to c2. X minus 1 by 5 log of 5z plus tan c1 equals to c2. 5 into x 5x minus log of 5z plus tan c1 equals to c2. V of x comma y comma z equals to 5x minus log of 5z plus tan c1 equals to c. The general solution is u equals to pi of v. U equals to 3x minus y equals to pi of v. 5x minus log of 5z plus tan c1. 3x minus y equals to pi of 5x minus log of 5z plus tan c1 y minus 3x. Okay, next another problem. Second one, solve xzp plus yzq equals to xy. Solution. Comparing the given equation, comparing the given partial differential equation is capital P, P plus capital Q, Q equals to R. We have where P equals to xz, capital Q equals to yz, R equals to xy. Legrange's auxiliary equation is dx by P equals to dy by Q equals to dz by R. Dx by P equals to xz, dy by Q equals to yz, dz by R equals to xy. Taking first two fractions, dx by xz equals to dy by yz, zz cancel, x equals to dy by y, 1 by x into dx equals to 1 by y into dy. Integrating on both sides, integration 1 by x dx minus integration 1 by y dy, integration 1 by x dx minus integration 1 by dy equals to c1. 1 by x dx log x minus log y equals to log c1. Log x minus log y, x by y equals to c1. U of x comma y comma z equals to x by y equals to c1. Next, taking last fractions, dy by yz equals to dz by xy. dy by yz equals to dz by xy, y cancel, x into dy equals to z into dz, x equals to c1 into y, x means c1 into y, dy equals to z dz. Integrating on both sides, c1 integration y dy minus z dz equals to c2, c1 into y square by 2 minus z square by 2 equals to c2, c1 y square minus z square equals to c2. V of c1 means x by y, y square minus z square equals to c2. Square y to y cancel, xy minus z square equals to c2. V of x comma y comma z equals to xy minus z square equals to c2. The general solution is u equals to pi of v. U equals to x comma y comma z equals to x by y equals to c1, x by y equals to pi of v. V equals to xy minus z square. U equals to pi of v, x by y equals to pi of xy minus z square.